Okay, so let's say I've got two vectors here. I've got this one, north, east, south, west, and I've got this one, north, east, south, west. Okay, and I've got a vector that is like this here. This angle is 23 degrees, which means that this angle is 67 degrees. Okay, and let's say that over here I've got a vector where this angle is 67 degrees, and this angle here is 23 degrees. So what if I told you 67 degrees northeast? Is that measurement referring to the vector on the left or the vector on the right? This is the problem, because you see both of these vectors are facing northeast, and they both do have a measurement of 67 degrees in them. So if I were to just tell you 67 degrees northeast, I could be referring to either one of these measurements. The problem is that that's not true, right? These aren't the same measurement. This one on the left has a higher angle towards the east, and this one on the right has a higher angle towards the north. These are not the same angle. So we have to have a special notation for this. And what we end up saying is blank of blank. So for instance, this red vector on the left, I would call this 67 degrees. Oopsie, sorry, I should write this over here. I would call this 67 degrees east of north. So what does that mean? That means that I draw a line north, and then 67 degrees to the east of that, that's where my angle is. So that is saying, east of north is saying that 67 degrees to the east of north is where my angle is. Likewise, this blue one over here, I would call 67 degrees north of east. Because notice, go to the east, to the north of that 67 degrees, that's where my line is. So, blank of blank notation will help you determine what you're referring to when you're talking about a compass rose and vectors. So, basically, you draw a line at the second direction noted, like north for this case, and then your angle is drawn to the other direction from that. So east of north, draw a line to the north, the angle is to the east of that. North of east, draw a line to the east, angle to the north of that. Okay, so using that information, I would like for all of you guys to try to draw the following vectors on a piece of paper. Estimate the magnitudes, just meaning like draw slightly different arrow lengths for this. You don't have to measure it out, just like guesstimate is fine. So please draw all the following vectors on a piece of paper. We have 143 meters, 17 degrees north of east, 224, 81 degrees south of west, 51 meters, 36 degrees east of south, 360 degrees, 63 degrees west of north, 76 degrees, 72 degrees north of south, and 190 meters, 41 degrees east of west. So please try to draw these out, and then pause the video and come back in just a minute. Okay, so let's try to draw these really quick. Here's my compass rose. Never eat soggy waffles. Let's go ahead and draw our vectors in. So the first one, I'm going to call this vector A, is 17 degrees north of east. Okay, so that means that from the east to the north of that 17 degrees is going to be like this. My magnitude's 143 meters, which is kind of on the smaller side, so I should make my arrow a little bit smaller, I guess. I'll put it like this, maybe. And then this angle is 17 degrees. Okay? Now, my second vector, I'll call that vector B, is 224 meters, 81 degrees south of west. So, south of west means that from the west, 81 degrees to the south is where I draw my line. 81 degrees is pretty close to 90, so I'll draw it like this. It's 224 is a pretty big measurement, so I'm going to go ahead and make my line pretty long. Make it a little bit shorter than that, I suppose. Maybe like this. We'll try. And then 81 degrees is going to be this angle here. Okay? Next, I'm going to call this vector C, 51 meters, 36 degrees east of south. Okay, so east of south means my angle is being drawn towards the east from south. So that means that I'm going to have it like this. It's 51 meters, so it's pretty short. My vector would look like that, maybe. My angle is here, and that is 36 degrees to the east from the south, okay? And then this one, vector D, 360 meters, 63 degrees west of south. Okay, west of north, excuse me. So 63 degrees west of north, go to the north to the west of that's where I draw my angle, meaning that this angle is going to be 63 degrees. And it's pretty long, so I'll give it about that magnitude, okay? Now, the next one, A, B, C, D, E, the vector E, is going to be 72 degrees north of south. Okay, how do we draw north of south? Well, we kind of can't. I put this in here kind of as a trick question, actually. So notice, to the north of south is either direction, right? I could just as easily draw 72 this way, or 72 this way. Both of those are technically moving towards the north, so we can't do that. If you have opposite angle directions, like north of south or east of west, like this bottom one has, you cannot actually solve that problem because north of south could be either direction. So what we would do is if a vector was in either of these two quadrants, we would call it west of south or east of south. We would never ever use north of south, and likewise, we'd never ever use the east of west. So these last two are actually impossible to draw, which I wrote in on purpose because I wanted to see if you guys would think, wait a minute, that's not possible. So only 4 of these are possible to draw. That's A, B, C, and D. E and F, actually, we would write in a different notation. You never use north of south or east of west. You'll never use opposites. All right, cool. Let's move on.